Welcome. In the high-stakes world of marine operations, some failures are just, well, they're not an option. Today, we're talking about the systems that keep massive vessels exactly where they need to be, their thrusters. We're going to explore why managing them takes a whole lot more than just routine maintenance. It really demands a total philosophy of integrity.
For any vessel, but especially for one that relies on dynamic positioning, a thruster isn't just a piece of machinery. It is the absolute linchpin of a safe operation. I mean, look at this. A failure isn't some simple mechanical hiccup. No way. It's a potential catastrophe, with huge risks to people, the environment, and the entire mission.
So, when the stakes are that high, our whole approach has to change. Just fixing things when they break or following a simple calendar schedule for maintenance, that's not going to cut it. We need something way more proactive, a system that covers these critical assets from the moment they're designed right up until their very last day in service.
So how do we actually make that happen? How can we guarantee that these incredibly complex machines will perform, flawlessly throughout their entire operational life? Well, the answer lies in a really structured, goal-oriented approach.
And this is where something called the Integrity Management System, or IMS, comes into play. Now, I want you to think of it not as another dusty binder of procedures sitting on a shelf, but as a complete, living framework that's engineered from the ground up to deliver consistent, predictable performance.
First things first, what do we even mean by integrity in this context? It's way more than just working. It's about performing a function effectively, efficiently, and safely. It's really the total measure of an asset's health and its capability to do its job right.
Integrity management, then, is the formal process for how we get there. It's the how-to. It makes sure that everything, from the people with the right qualifications and training, to the systems, the processes, and all the resources, is perfectly lined up to deliver that integrity, day in and day out, for the asset's entire life.
This visual gives us a great look at the architecture of an IMS, and you can see it's not a simple checklist. Right at the heart of it is a technical authority. This is a person, a single point of responsibility, who's accountable for the whole system, and they oversee the three key functions that make it all work.
So let's break down those three pillars. First, you've got performance. This is where you define what good actually looks like. What are our goals? Second, there's assurance. This is your internal system for doing the work, all the maintenance, the inspections, the competency checks to meet those goals. And third, verification. This is the crucial independent check that proves your system isn't just busy, but it's actually effective. It's kind of like set the goal, do the work, check your work.
And this system isn't something you just set up once and forget about. Oh no, it spans the entire life of the asset. It starts right back in the design phase, literally building integrity in from day one. It continues through construction, commissioning, the entire operational life, any modifications, and it even helps you plan for a safe decommissioning. It is a true cradle-to-grave philosophy.
Okay, so theory is great, but how do we translate this big concept into a practical plan for, say, a thruster? What does it actually take to build a specific thruster integrity management system, or a TIM? Well, luckily, the source material gives us a super clear roadmap. You start with the big picture stuff, a high-level policy and a detailed plan. From there, you get really specific. You define performance criteria, you use risk assessment to pinpoint the most critical components, and then you build your assurance and verification systems around what truly matters most. It's a logical step-by-step process.
And this right here, this is a hugely important distinction. An IMS is not some generic procedure you can just download off the internet. It's a goal-based process. What that means is every single system is custom-built to fit an owner's specific assets, their unique operations, and their business objectives.
Now, this is a perfect example of what those goals, those performance criteria look like in the real world. See? They aren't vague wishes like, be reliable. They are specific, measurable targets for things like availability, repair times, and capability. This is exactly how you turn that abstract idea of reliability into hard, auditable numbers.
So, with a complex piece of kit like a thruster, where do you even begin to focus your efforts? This is where you identify your performance critical elements, or PCEs. You do a formal risk assessment that helps you zero in on the specific components. We're talking gearboxes, seals, control systems, where a failure would have the biggest, most dangerous impact. This is really the heart of the whole process, because it ensures you put your resources where they'll make the most difference. Okay, so you've identified what matters most. Now what? How do you make sure your system is actually protecting it? Well, this brings us right back to those essential checks and balances: assurance and verification.
It is absolutely vital to understand the difference here. Think of it like this. Assurance is the internal doing. That's your maintenance teams on the ground, your engineers monitoring performance. Verification, on the other hand, is the external checking, an independent, competent person coming in to assess if your system is truly effective. It's like the difference between doing your homework and having the teacher grade it. You need both to prove you actually know your stuff.
A really solid verification scheme relies on these key elements. First, a written scheme of examination, which is just a formal way to document your inspection and testing methods. Next, you need key performance indicators, or KPIs, to track progress against your goals. And finally, you have regular audits by an independent expert to check the health of your entire process. Put them together, and they create this amazing feedback loop for continuous improvement.
All right, I know what you might be thinking. This sounds like a lot of work. So, what's the real payoff? How does this actually impact not just safety, but the bottom line in your operational efficiency?
Well, the benefits are immense. You're shifting from a reactive, really expensive break-fix model to one that's proactive, predictive, and way more efficient. And this translates directly to less downtime, optimized maintenance costs, a longer life for your asset, and higher availability. Basically, it turns maintenance from just another cost into a powerful strategic advantage.
And this number right here really shows the power of the whole system. An abstract goal like high reliability becomes a concrete, auditable target like 95% availability. Now, everybody in the organization has a crystal clear goal and, more importantly, a system to help them achieve it. Ultimately, that's the real core of thruster integrity management. It's not just about preventing failures today. It's a strategic investment in the future safety, reliability, and profitability of your entire operation. So the question for your own operations is pretty simple, but it's also profound. Are you just maintaining for today, or are you truly ensuring integrity for tomorrow?